Afiq. Luqman. Kita. Nurhana ni. Okay, Assalamualaikum, selamat pagi. Boleh send your name and location. Apa? Sudah baik dah, memang. Okay. Sama apa kita? Siapa ni? Siapa ni? Thomas Warren. Muhammad Amin. Misha Wonderful. Okay, thank you. Assalamualaikum, selamat pagi. Thank you for joining. And ada berapa orang ni? 14. Syazwan, Luqman Hakim, Seremban, Tanish Kamat, Muaz, Seremban, Afiq Keluang, Hakim Rafi Selangor, Hazan, Kuala Lumpur, Muhammad Amirul, Kuala Terengganu, Syazwan, Kuantan, Nurhanani, Pahang, Fairul Izwan, Kudai. Okay. Mana yang dekat Selangor? Siapa ni tadi? Selangor. Salam Hakim Rafi'i. Shah Alam teruk ke dia punya kes COVID tu?
Macam teruk. Dekat kawasan rumah saya dah ada lah seorang at least. Kawasan perumahan.
Kawasan perumahan. Ni apa number of cases ni berapa dah semalam?
Saya pun tak check doktor banyak sangat.
Ya. Numbers tu lonjak-lonjak tapi itulah. Mana betul-betul detail dia dong. Tak beritahu. Okay, so tak apalah. So just be careful. Okay, so variant yang latest ni agak virus tu agak kuat. So elakkan keluar kalau boleh. BTM pun kalau kamu kan baca berapa orang apa yang dekat college tahan dah college tu. Siapa yang lambat keluar tu tak balik raya. Raya kat ETM je. Okay, Fakul Razi Muar. Okay, nampaknya banyak kamu semua dah berselamat. Selamat pulang ke kampung. Bila balik sini? Balik UTM, Hakim?
Tak tahulah. Tengok. Tak tahu lah.
UTM bagi tarikh hari tu berapa? 17 dah mula-mula.
Fasa first 17 lah. Tapi
17-18 right? Okay. Abdul Muaz, Seremban apa cerita? Seremban kes banyak juga ke? Hari tu tutup semua, semayang pun tak boleh kan? Masjid. Lepas tu semayang IDPT buat kat rumah je lah. Oh, dapat kat masjid. Oh, kena datang awal lah. Siapa datang awal dapat lah 50 tu. Oh, ni daftar awal. Yelah. Dia dah bagi PKP seluruh negara kan. Tak nak bagi orang gerak sangat. Saya semayang kat rumah je lah. Okay, so tak apa, berjaga-jaga dan siapa yang berani boleh daftar vaksin. Siapa yang tak mau pun tak apa. Saya pun tak daftar vaksin ni. Tak mau saya daftar. Okay, so berjaga-jaga berhati-hati. Kalau demam, sakit tekak kan ambil lah ubat. Kalau pergi hospital kan dia tahan. Kena swab test semua positif, terus kena pergi ni pula. Saya nak share apa ni, saya nak share. Okay, buat apa seorang. Share screen. Okay. Stop sharing. Stop sharing. Okay, so ini itulah. Memang saya pun kat kampung lagi sebenarnya. Work from home, so tengah fikir juga nak bergerak ni. Plan ni 20 bulan lah nak bergerak ke, saya daripada utara di Teluk Intan sekarang. So saya akan ke Kuala Lumpur. Anak saya ada seorang kat sana. Lepas tu balik Johor. Okay, so saya di mood raya. Mood raya ni tak bekerja lah. Lepak je. Okay, so welcome back. Kamu apa tadi? Fairul dapat go through tak video dan lecture slide on VBEL?
Sikit-sikit.
Ya. Okay, bagus. Dapat go through tu pun dah excellent lah. Okay, so Tanish ada soalan ke? Okey ke? Boleh faham ke dia punya step-step untuk selection of the VBEL?
Kalau tengok video tu boleh faham, boleh ikut.
Boleh kot. Okay, so one thing is dia punya itulah step-step kan for you to select ataupun to choose based on problem kan, but you have to understand kan, this is part of the design okay, of your design process. So if you were to design a mechanical system, then sometimes we will require the system to have transmission of power through belting. Okay, so VBEL is one of the best option lah. Okay, and then you have to consider the different factors in terms of your selection. Okay, and that actually is covered some dia punya fundamental of the selection. Okay, you kena baca lah sebenarnya detail dia dekat dalam buku tu chapter 19. Okay, chapter 19. Dan sebab of course, okay, depending on material kita pakai, what kind of material are you using for the belting? Is it the leather? Okay, leather, they have different values of friction coefficient. Okay, different level of slippage. Okay, kemudian if you are using rubber, okay, rubber normally they will use 0.25 friction values, friction coefficient. And then if you have, for example, plastic types of belting, okay, then that will be more 0.3 just like say. Okay, so that consideration will be taken into consideration lah. Okay, so many things, but that details and you need to baca lah sebenarnya. Okay, and for every system. For example, kita ada one is V-belt, kemudian ada flat belt. Okay, ada flat belt. Dan dan juga apa ni? So these are the cost effective, okay, for transmission of power. Then using rather than using gear. Okay, so apa ni sebenarnya dia cerita pasal what is the V-belt. Okay, so okay, kemudian all these different apa ni term. Okay, the P1 tight side, P2 PC tension due to centrifugal force. Okay, so okay, this is the important part lah untuk V-belt. Ada soalan tak ini? Tamil Swaran, okay with this? Saya ambil soalan ni kalau boleh. Okay, P1 apa is the force tau. Force is the force. P2 is the slack. P1 is the tension part. PC is the force due to centrifugal. Okay, normally when we have higher speed, okay, where centrifugal force too is big enough to be included. Okay, but tengoklah depend on the speed of your system. Okay, so that is for PC. Okay, and then okay, if you have the with the V-belt, okay, the equation tu lah become P1 minus PC on the okay, the formula. P1 minus PC over P2 minus PC equal to E to the power E sin beta. Okay, so sin beta tu is the shift punya angle. Shift angle tu is to beta ni. So boleh double check. Okay. Okay, so this is for V-belt case. Okay, so ada soalan tak? Okay, so ada P1, P2, ada PC, kemudian V, the rotation. So ada two part. Remember, there will be the tight part dan ada kemudian is F over sin beta. This is for especially for V-belt. Sebab if you have a flat belt, you're just going to have F. F is the friction coefficient. Okay, so normally E to the power of F theta, Fv, sorry. Okay, but for V-belt in case, we're going to kemudian, okay, so we are going to focus on V-belt. Ada V-belt. Okay, and okay, so this is the yang apa tu dia punya material dan composition. Okay, so normally it is on wrapped V-belt. Okay, dan okay, so you have this different section lah. Okay, so general, okay, for Mitsubishi, the one that we are using is applying this 5 types ABCDE. Classical used for power transmission. For replacement. Okay, normally ABCDE itulah. Okay, so kemudian this is the detail of ABCDE. So remember, it is a standard. So the dimension tu is given, okay, for different type. Okay, ABCDE. A the smallest, okay, to the E biggest. A Mitsubishi catalog. Okay, so remind me, did I pass to you already the Mitsubishi catalog? Saya pun tak ingat. Okay, so refer to Mitsubishi catalog, table 1.2 to table 1.6 for belt code, outer length LA and datum length LD. Okay, so ada banyak this different term. Okay, so just get used to the 124. Okay. So set condition required, SR apa ni, the speed ratio kan. Speed ratio, okay, and motor and ada soalan tak? Saya pun malah nak cerita panjang. Check design power, okay. So slowly go through the equation, okay. You just need to remember the step ataupun yalah, nak ingat kadang payah, you just need to understand lah, okay, the step. Okay, starting from this design power HD, itulah biasanya HD. Okay, start with your design power. HD to normally they'll give you, or you have to from the power from the motor, and then you have to start find your service factor in KS. Okay, so KS from, they give you the information on KI and KE, then you will refer to the table for each KO, KI and KE and select. If no information is given, you will take 0. Okay, HD is the transmission power normally from the motor. Okay, then first calculate your HD using that HD and KS. Okay, so this is the table. So just be extra careful. Okay, from the information given, what is the type, okay, that you have to use. Okay, normally we are going to for driving unit. Okay, driving unit, if they don't mention anything, okay, you should select the left one. Okay, maximum power less than 300%. Okay, and then the idler factor. Okay, if you go through the video. Okay, the video actually explain in detail, okay, of the selection idler correction factor. Afiq, okay lah Afiq, on the idler, apa ni, KI. Nampak tak tengok?
Jadi doktor, untuk yang tu memang diguna Mitsubishi punya katalog je kan?
Ya, ada katalog dia. Katalog tu nanti saya akan sharekan balik. Saya rasa macam maybe saya belum share lagi. Okay, so all this information will be provided. Yang penting you have to understand how to use the information lah. Okay, so because is not very practical lah to memorize everything. Okay, so okay, you have the manual, then you have to understand how to apply and use the manual. Okay, based on the problem given or whatever assumption. Okay, then you will select appropriate value for this constant. Okay, this is idler correction factor. So this is the one where related to the level of the tension lah sebenarnya. Okay, of the belt. Kemudian KE, environment correction factor. Okay, so if they mention, okay, kena ada the wording is there, then you apply. If not, okay, they don't provide any information, you just consider it to be 0. Okay, kemudian this is the one. Okay, once you find your HD tadi, okay, the x-axis punya value. Okay, once you get your HD yang bawah tu, okay, then you will refer to your RPM, the end for the smaller or the driver pulley. Okay, then you will start to select or to get your your belt type A, B, C, D, E. Okay, so tengoklah maknanya if you have your pulley or if your system to have high design power, okay, and low speed, okay, then you will have on the right side of the V belt, okay, DE ataupun CDE lah maknanya. Okay, but if you are normally is with high or lower design power and higher speed, then mostly A and B. Okay, so depending on your application, that will be your base of selection. Okay, and then okay, so this is another term, minimum pulley datum diameter. Okay, so here the main ABCDE. So you can, once you select, then you have to continue. Okay, the minimum pulley diameter given 3, for example, okay, you have. Okay, kemudian what is this? This is table 1.5. Okay, then top belt width, datum width, height of belt. Okay, tak apalah. Okay, then we will. Okay, determine the belt length. Okay, okay, interim means is the apa ni, initial ataupun before the final value. Okay, determine the interim belt datum length L prime D. Okay, L prime D is equal to 2C plus 1.57. D besar plus D kecil. Okay, select the standard belt length LD closest to L prime D from catalog. Okay, so okay, find L prime D, kemudian find LD, okay, from the catalog. Okay, the closest to the value. Okay, center distance C. Okay, so that is the formula given. Kemudian B ada value dia, find the B value. If the center distance is confirmed, use the following formula to determine interim belt datum length. Okay, so you have option, okay, to find L prime D. Okay, so ada 2 equation lah. Okay, for finding L prime D. 2C plus 1.57. Tengoklah macam yang number 1 tadi sikit kan, dia punya number. Okay, determine the required number of V belt or belt. Okay, this is one of the the important question lah. Normally they will ask you, okay, to find what is the required number of belt. HD yang tadi tu. HT times KC tu. Kemudian HC ni. Okay, HC is given by HS plus HAKC. Okay, so this is another equation. Okay, so slowly follow through the step and should be not that difficult. Okay. Harzan okey ke Harzan? Ada soalan tak?
Okay, doktor.
Okay, this is value HS dan HA. Okay, HS dan HA. HA tu based on speed ratio. Tengok speed ratio. Speed ratio tu is tengoklah dia punya diameter, the D besar dengan D kecil tu, you can get the speed ratio. Okay, and then select the speed ratio. Okay, so saya pergi laju sikit, so you need to stop ni kalau you tak faham. Okay, bell length correction. Bell length correction ni KL. Okay. Kita tengok dulu. To use biasanya pakai yang the first column tu DD minus small DDOC je. Okay, so if you go through the video yang they give you the example at the end, then should help you quite a good explanation lah. Okay, kemudian angle of wrap. Provided. Okay, so this is the form untuk PC. Tension due to centrifugal force. Okay, this formula for one on from Juvenal. Okay, so this is based on Juvenal, kemudian ada weight. W is mass per unit length. Okay, the equation dia kan, you have to apply. A, B, C, D. Y. Okay, Y unit S apa, bukan SI unit tu, pound per piece. Tension on the tight side. Okay, tension on the tight side ataupun P1 ni tadi ni. Tension on the slack side. Okay, so all the formula. So be careful. Slowly go. Okay, follow the step. Bed loading. Effective tension. Torque transfer. Okay, kita tengok example. Okay, this is one example ataupun one exercise man. A motor of given horsepower and speed drive and input pulley. Dia pecah dia punya gambar ni sikit. Okay, so you are given an input pulley of known diameter. Diameter is given 90 mm. And an angle of wrap. Angle of wrap dah bagi 165. The size 2L. Okay, ini begitu LV belt. 2LV belt have a known unit weight. And angle beta. The maximum belt tension is 675 Newton. The coefficient of friction is 0.2. That means the number of belt required. It is a multiple V belt. Unit weight for each belt is 2 Newton per meter. Power input is 20 kilowatt. P maximum equal to P1 equal to 675 Newton. Friction force F is 0.2. Beta is 18 degree. Size to LV. Size to LV. Okay, to LV. Okay, tak apa. Okay, so 99 mm diameter driving pulley and small end 1750 RPM. Angle of wrap 165. You need to find number of belt. Okay, so kena projeksi center distance between the two pulley, then diameter of the big pulley. Okay. So these are the information known. So given is P1 sorry 675, N is 1750, V is 165, unit weight, power 20 kilowatt, F beta, D drive 99 mm. Okay, apply equation P1 minus PC. P1 minus PC divide by P2 minus PC. P1 minus PC divided by P2 minus PC. P1 F ada, V ada, SI beta ada. V is V D drive ada divided by 2 times N ada. PC is unit weight 2 divided by G times V2. Okay, so the first step is to find the V velocity. Okay, so the velocity can be find using dia punya diameter dan times the rotation and so D drive 90 tadi kan, 90 tukar per the unit, so times the N berapa tadi, N 1750. Okay, unit weight is 2 Newton, so D tadi 99, so 0.9. Okay, so start with V sebenarnya. Okay, so once you get your V value, you can find your PC. PC is the equation unit weight divided by G times V square. Okay, so you have your PC value, and then P2 from equation 19.3. Okay, P2, so ada PC dah ada, P1 is given, find P2. Okay, P2 dapat 118.856 Newton. And then you can find the T is the torque. Okay, torque is P1 minus P2 over D drive divided by 2. Okay, the torque P1 minus P2 divided by the radius of your pulley. Okay, you get your torque 27.529. So the power for the belt is N times T. S times T. Okay. Rotation speed times the torque. Okay, and then for N numbers of belt to be used is power divided by power belt. Okay, so this is one method, okay, to solve if you are given, okay, the P1 value, the D value, the small d value, okay, and what else you need weight for belt, and then you are asked to find the numbers of belt required. Okay, so power tadi berapa? Power is given 20 kilowatt. Power is 20 kilowatt. 20 kilowatt divided by 5. 3.9 belt. Okay, so 3.9 belt, meaning you have to round it up. Okay, so give you 4 belt. 4 belts are required. Okay, ada soalan for this question. Example exercise. Understand the step dan understand the technique that you can use. This is one example. Okay, so starting from the equation, the main equation ni yang P1 minus PC, okay, equation 19.3, and then start finding your V value, the velocity. Okay, the velocity is just rotational speed divided by the radius, okay, of the small pulley, of the driver pulley. So you get your V, and then you can get your PC, okay, when you have the V value, okay, with the unit weight. Okay, unit weight divided by G okay, times V square. Okay, and then find your P2 and find your torque, and then find your power belt. Okay, and then numbers of belt is just your power divide the requirement of the power belt. Second example. Okay, ada lagi nak masuk sama-sama. Amirul Zainal, Arzan Afiq. Lagi ada Tamil Soalan Fakur Razi, Amirul Syah, Farul Izwan. Farul Izwan okey ke? Farul.
Okey Doktor.
Amin.
Okey Doktor.
Amirul.
Baik Doktor.
Fakur Razi.
Okey.
Okay, next example. Okay, so tengoklah kan, maknanya there'll be formulas, okay, that you need to understand concept and the way to use it, to apply. Okay, so tadi one technique for you to get the numbers of belts. Okay, so because normally V belt ni biasanya they'll use the multiple belt lah. Okay, so up to 12, sometimes 12 V belt at one system. Okay, so they provide the or better efficiency than performance. So rather than using one belt, okay, so they have this multiple V belt. So you need to basically calculate the requirement, then select what is the numbers of belt to be used. Okay, next. Yeah. Okay, given a pulley, rotational speed, radius, and angle of wrap, drive a V belt with known friction, weight, and maximum tension. Okay, so V belt question will be the first question on test 2. So just make sure you get and understand the step. Okay, ini pun saya ambil soalan ni from the book. Okay, determine the maximum power transmitted by the pulley. Okay, maximum power transmitted by the pulley. So you are given V belt beta 18 degree, F is 0.2, N is 4,000 RPM, R is 100 mm. Pulley radius. Okay, so be careful. Radius ke diameter dia bagi. Okay, so this one R radius, pulley radius is 100. P is 170, angle of wrap. Bell maximum tension is 1300 Newton. Bell unit 1.75. Okay, so assumption, the friction coefficient is uniform throughout the contact area. Okay, so assumption ni you need to state for your penis. If you have your project okay, nanti ada project, final major project nanti. Okay, in your selection of V belt, for example, okay, you have to include the assumption. So this statement, okay, can be used later on. Okay, the friction coefficient is uniform throughout the contact area. The effect of centrifugal force is important. It's going to be dealing with high speed. Okay, so analysis. Tengok. Okay, this is another analysis. Okay, from equation 19.2, PC is the unit weight, 1.75 divided by G times V square. V square is your N 4,000 divided by 60 times 0.2 pi. Ini dia dah. Okay, so the detail. And 0.2 pi. V square tadi. So daripada ni dapat apa? PC 1.75 weight tadi G times V square. Okay, V square is 4,000 RPM divided by 60 times 0.2 pi. Pi apa tadi? Macam tadi kat start kan. Okay, so this is the first step. Okay, you get your PC value. Okay, once you get your PC value, okay, P1 is given 1300 to the maximum tension to is normally is your P1. P1 to is the greater of your force or tension in your system. Okay, so once they give you bell maximum tension to 1300, maximum tension is your P1. So P1 minus PC kan, PC is 313. So P2 tak tahu. we have to find P2. So 0e to the power or 0.2 sin apa tu? Sin beta times 170 pi divided by 180. Okay, so this is the step to find the equation. Kemudian kita find P2 lah. Okay, so find P2 is 458 Newton. Then find the torque. Torque is P1 minus P2 times R. Okay, so the torque is the difference between the force times the distance, the radius. So radius dah bagi 0.1. The difference between P1 and P2. And then get the torque. Kemudian from equation 1.2, tengok ini related to chapter 1, the power W dot is N times T, NT times 9 divide by 9549, itu equation. Okay, that is the equation for power. So W dot, okay, 4000 is the N value, the small n, times T, NT divide by 9549. Okay, so you get your apa tadi tanya maximum power. Maximum power transmitted by the pulley. Sekejap ni belum lagi pakai apa. Okay, a pulley of given rotational speed. Okay, next soalan. A pulley of given rotational speed, radius and angle of wrap drive a V belt with known friction, weight and maximum tension. But A, 2 V belt are needed. 2 V belt are needed. B, a single V belt with twice the maximum tensile capacity is used. Okay. V belt, single V belt with twice the maximum tensile capacity is used. Between the power transfer the pulley for case A and B. Okay, so this is just extension of the same question tadi. But now, okay, for case A, 2 V belt. 2 V belt are required. And B, 1 V belt with twice the cross-sectional area. Twice. Okay, so apa ni? Assumption if 2 belts are used, each will have the same capacity and the load will be shared equally between them. Okay, that is the apa ni? The key, okay, to the solution. If a belt with twice the cross section is used, there will be no loss in the tensile strength capacity because of a size effect. Okay, so what are you? Okay, nanti saya akan share kan this one. So you just need to go through. Okay, if 2 belts are used, each will have the same capacity and the load will be shared equally between them. Okay, if a belt with twice the cross section is used, there will be no loss in the tensile strength capacity because of a size effect. Okay, for case A, each of the two identical belts could transmit 35 kilowatt. Hence, total power capacity is 70. Case A, each of the two identical belts could transmit 35 kilowatt. Hence, total power capacity. Let's see, 35 kilowatt. So, for case A, each of the two identical belts could transmit 35 kilowatt, hence total power capacity is 70 kilowatt. For case B, doubling the section would double M prime, giving PC 626 to 6 Newton. Doubling C and P1 with no change in EF P over and beta would double P2, thus power capacity is double in case A and B.
Doktor,
Yeah.
apa maksud same capacity? Same capacity share equally.
Namanya nak atas saya, buan tadi ya. Okay, if two belts are used, each will have the same capacity and the total will be shared equally between them. Okay, so ini tadi based on dia punya question. Okay, dia required two belt. Okay, so two belt tu, so each belt tu will have the same capacity. Maknanya for example, from the extension of question number 1 tadi, okay, the power for the belt is 35. Okay, tengok yang number 4 ni kan. Okay, 35 kilowatt. So, kalau ada dua belt, then that each belt 35. Ya.
Kenapa?
Okay, so 35 for 1. Okay, so jadi ada dua. Is going to setiap belt tu will have 35. So you can have 70 total power capacity. Okay, so that is the punya meaning dia lah. Okay, so each belt tu capacity is 35. So they'll be the same.
Aduh, ya Allah.
Okay, ada lain soalan? Okay, saya akan share minta kamu try lah. But stop transfer. Okay, so okay, boleh take a break sekejap 5 minit. Saya tengok balik mana soalan satu lagi nak bagi. Sekejap. Agak lagi sekejap. Sekejap. Makan atuk. Oh, Aisyah.
Sekejap, Abi nampak kerja sekejap. Sekejap, tunggu sekejap. Sabarlah pihak tu. Jangan ni. Kita dulu sekejap. Ya, dia datang sekejap. Bagi kerja sekejap. Sabar. Sabar. Sekejap, Abi nak bagi sekejap student kerja sikit. Ada. Sabar. Kisah. Sabar. Boleh sekejap bang, bagi kerja. Ada boleh pergi tadi. Sekejap. Bagi kerja sekejap, boleh pergi. Bawa dia masuk lagi. Okay. I have shared soalan question on I think test 2 punya sample.
So I would like you to try question 2 on the test 2 punya paper and complete and submit, okay, by next week. Okay, apa ni, by next Sunday. Okay, give it a try. Question 2 on V-belt problem. So I have to stop here for today. So saya nak kena bawa sekejap anak pergi klinik pula. So forgive me, just give it a try soalan on that sample. Okay, so question 2 on the test 2 and one is from the catalog 1, but anyway I will insyaAllah assist you later. Okay, give it a try. Nanti kalau anything you can just message me. Dan that's all for now. Okay, so thank you for joining the session. Dan we'll meet again insyaAllah. Okay, terima kasih dan sorry.
Thank you, Dr.
Okay.
Okay.